Welcome to the Deep Dive, your shortcut to being truly well informed. Today, we're plunging into a topic that, well, it pretty much underpins nearly every digital interaction and big business decision these days: data architecture. If you've ever wondered how all that raw information gets turned into actionable insights, the kind that really drive companies forward, then you're definitely in the right place. This deep dive is really for anyone curious about those sort of unseen blueprints that make our digital world tick. Maybe you're thinking about a career in data engineering, maybe you're already in the thick of it, or perhaps you just want to be, well informed about how modern businesses operate. Our mission today: let's try to unpack the core ideas, move past the jargon, and really grasp the strategic heart of data architecture. So, let's get into it.
Okay, so to really start, we have to ground ourselves in the fundamental goal, right? The objective of any data project and really any data architecture. It's never just about hoarding data. I mean, it's always fundamentally about solving real business problems. That could be anything from, say, reducing system costs, making things more efficient, to enabling a company to make those truly data-driven decisions that affect their bottom line, their future. There's a great definition in the Fundamentals of Data Engineering book by Joe Rees and Matt Howersley. They put it as: data architecture is the design of systems to support the evolving data needs of an enterprise,
Okay.
achieved by flexible and reversible decisions reached through a careful evaluation of trade-offs.
That's quite a packed definition. What jumps out at me there is design of systems. Makes me think of, well, building something substantial like a skyscraper. You wouldn't just start throwing up walls without a plan, would you?
Exactly. Yeah, the building analogy works quite well, actually. But let's refine it a bit for data. Imagine an architect designing, say, a modern office tower. They're not just sketching, right? They're meticulously planning the foundations, the structure, how people and utilities move through it, how different floors connect, and even how the building might need to change later, maybe add a new section or reconfigure the inside.
Right, adapt to future needs.
Precisely. And in the same way, a data system isn't just about dumping data somewhere. It needs components like good storage solutions, the right software, clear data flows, user interfaces, ways to transform the data, staging areas, maybe a data warehouse for analysis, and ways to report on it all. Every piece has a job, and that key phrase in the definition, flexible and reversible decisions, that speaks to planning ahead.
Flexible and reversible.
Yeah. It means if business needs change, or maybe a technology you picked isn't working out as hoped, you can adjust, you can adapt, maybe even swap out a component without having to tear down the whole thing. It's really about engineering for the long haul, for change.
Okay, so if we're talking about this kind of complex engineering, it seems like it naturally splits into two related parts: figuring out what needs doing and then how you're actually going to do it. Which makes me think, for you listening, how does this difference affect how you think about data in your own work or projects?
That's exactly the point. Data architecture really does have these two sides, and they're totally interwoven. First, you've got what we call the operational architecture. This is the why. It's all about the business goals, the strategy, the problems you're trying to fix. When we talk to businesses, the questions aren't usually which database should we use. They're more like, for an e-commerce site, perhaps, how can we get people to abandon their carts less? Or why isn't this product category selling well? Or maybe, how do we make sure our customer service team gets accurate order info instantly? The focus is squarely on the business impact, for everyone involved.
So it's really defining the target first. What's the business value we're chasing before we even think about the tech solution?
Precisely. And a key insight for operational architecture is always start with the end in mind. That sounds like basic project advice, but for data architecture, it's absolutely fundamental. If you don't have a super clear grasp of the specific business problem, well, you risk building these beautiful, complex systems that collect tons of data but don't actually deliver real value. Another really vital point is to iterate and evolve. Business needs change constantly. So your architecture has to be agile. You build for today, sure, but you have to plan for tomorrow's growth, tomorrow's shifts in strategy or the market. Build in that flexibility from the start. And finally, every single data solution needs a clear, measurable focus on impact. Can you directly link your data project to, say, happier customers, smoother operations, or better decisions? That value needs to be clear, ideally quantifiable.
That's a really critical distinction. Define the destination before choosing the car, essentially. Which naturally brings us to the other side, the how. Once we know what we need, how do we technically build it?
Right. And that's where technical architecture steps in. This is all about the specific tools, the technologies, the methods. the blueprint for how data gets ingested, stored, processed, and analyzed to actually meet those operational goals. Now, if you've ever glanced at the data tech landscape, I mean, it's vast. It can feel overwhelming, like a galaxy of tools.
Oh, absolutely. The sheer number of options out there is dizzying sometimes.
It really is. But the good news is you don't need to know, let alone use, all of them. Strategic selection is absolutely key. A fundamental insight here for technical architecture is that simplicity is key, honestly. Every bit of unnecessary complexity you add isn't just inefficient now. It's like taking out a loan you'll have to repay later with interest, usually in the form of maintenance headaches or unexpected failures. A really elegant architecture is lean, purposeful, like a well-oiled machine. That makes it easier to maintain, easier to scale, and leads to fewer mistakes. Another critical insight. Choose the right tools for the job. There's no single magic bullet technology. For example, you might use a data lake. Think of it like a huge, flexible repository for storing raw, messy, unstructured data. Invaluable for future analysis you haven't even thought of yet.
Okay, like a digital attic.
Kinda, yeah. And that's very different from a data warehouse, which is more like a highly organized library. Data there is clean, structured, optimized for really fast, complex queries and reports. They do different things, but they often work together.
So it's about understanding the job each tool needs to do and picking the best fit, not just grabbing the newest shiny object.
Exactly right. And this is important. Even if your data volumes aren't huge right now, build for scale and flexibility. Assume growth. Plan for big data because it often arrives sooner than you think. This means choosing technologies that can scale horizontally, just add more machines and are modular, so you can swap pieces in and out without a massive rebuild. This also connects directly to embracing automation. Automation is huge for efficiency and accuracy. Think about automating data ingestion, the whole ETL or ELT process, monitoring systems, checking data quality.
Likes the repetitive workout.
Yes. It reduces manual effort, cuts down on errors, and frees up your valuable team members to focus on more strategic, higher-value tasks. And, maybe most importantly today, you absolutely have to prioritize data security and governance. It's non-negotiable. Embed security, privacy, governance right into the architecture from day one. That means strong access controls, encrypting data everywhere when it's moving and when it's stored, using tools like AWS Key Management Service, for instance, and making sure you comply with regulations like GDPR or CCPA. It cannot be an afterthought. It's foundational.
So these two architectures, operational and technical, they're not separate silos at all, are they? They're like two sides of the same coin, constantly feeding back into each other. It's not either. It's a real partnership. Okay, here's where it gets really interesting, I think. Let's make this concrete. Let's unpack it with a real-world example. Imagine we're building the data architecture for a busy online store and e-commerce platform. How do those whys and hows actually play out?
Yeah, this is where it all comes together beautifully. For an e-commerce platform, the operational business needs, the whys, usually cluster around 5 key areas. First, customer experience. This isn't just fluff. It means using data for things like personalized product recommendations, making the website easy to navigate, ensuring customer service is quick and helpful because they have the right info. The goal is making each customer feel like you actually know them.
Personalization.
Exactly. Second, operational efficiency. This is about streamlining everything behind the scenes. Automating inventory so you don't run out of popular items, speeding up order processing, optimizing shipping to cut costs and delivery times. Every bit of friction removed helps the bottom line and keeps customers happy. Third, marketing insights. Really understanding how customers behave. What campaigns work? Where should products be placed on the site? How do you turn browsers into buyers? It's about using data for smart growth. Fourth, vendor management. Improving how you share data with your suppliers. This leads to better product availability, maybe better pricing, tighter quality control. Good data flow here makes your whole supply chain stronger.
Right, connecting the whole ecosystem.
Yes. And fifth, super critical today, compliance and security. This means being rigorous about protecting customer data privacy, securing transactions, and making sure the platform follows all the relevant rules and regulations like PCI DSS for payments or local data laws. Trust is paramount.
Those are really clear business drivers, the whys.
Yeah.
So now, the big question, how do we translate those needs into the how, into the actual layers in a technical architecture that can deliver all that?
Excellent question. Okay, let's walk through technical layers for our e-commerce example, and we'll tie them back to those operational needs. First up, the data ingestion layer. Its job: collect data from everywhere. Website clicks, server logs, app usage, vendor updates, inventory changes, support tickets, everything. For this, something like Apache Kafka is often a great fit. Why Kafka? Because it handles massive streams of data in real time, reliably. Every click, every order, every stock change gets captured instantly, even when the site is incredibly busy. This real-time aspect is key for those instant recommendations or inventory updates.
Okay, capturing everything as it happens.
Exactly. Next, the data storage layer. This is where all that captured data lives. You typically use a combination, maybe AWS S3 as your data lake. Think of it as that vast, flexible storage for the raw, original data in whatever format it arrived, your ultimate source of truth. Alongside that, you'd likely have a data warehouse, maybe Amazon Redshift or Google BigQuery. This is where clean, structured data goes, optimized for fast analytical queries needed for those marketing insights or operational reports. And you might even layer something like Delta Lake on top of your S3 data lake to get better reliability and transaction support, kind of bridging the gap.
Got it. Lake for raw, warehouse for refined.
You got it. Then, following storage, you need the data processing and transformation layer. This is where the magic happens to turn that raw, sometimes messy data into something clean, validated, enriched, and structured for analysis. Apache Spark is often the powerhouse here. Why Spark? It's designed for processing huge data sets very efficiently, both in batches like running daily sales summaries and in real time like updating a customer's profile right after they browse. It gets the data ready for the analysts and the algorithms.
Okay, cleaning and preparing the data.
Then comes the data analysis and business intelligence layer. This is where you actually generate the insights, make the decisions, power those customer experiences. You'd use tools like Tableau or Power BI for visual analytics. Let business users explore the data, spot trends, without needing to be programmers. And for the more advanced stuff, like building those recommendation engines or forecasting demand, you'd bring in machine learning tools like TensorFlow or PyTorch. This is where you get that really smart personalization and operational prediction.
Driving the actual business outcomes.
Precisely. Now, equally vital, the data security and compliance layer. Purpose, non-negotiable. Ensure privacy, security, and meet all those regulations, GDPR, CCPA, etc. This isn't one tool, it's a multi-layered approach. Strong access controls who can see what data, encryption everywhere, data moving, data stored using things like AWS KMS, regular security audits, and building compliance checks right into your data pipelines. It has to be baked in, protecting customer trust and avoiding hefty fines.
Absolutely essential.
And finally, the data integration and API layer. This layer is all about connecting your e-commerce platform smoothly with external systems. Think vendor portals, shipping companies, maybe CRM tools. You build APIs, application programming interfaces to handle this data exchange. For simple, flexible connections between services, RESTful APIs are very common. For more complex situations where you need to pull specific data from multiple places efficiently, GraphQL can be a really powerful option. This layer is key for that seamless vendor management and efficient operations across different systems.
Wow, that is a really thorough breakdown, and it perfectly illustrates that back and forth, doesn't it? The why driving the how. From a simple website click all the way through to sophisticated customer insights, it all flows through these carefully designed layers, each one built with a specific purpose, directly addressing those core business needs. It really highlights that the art of data architecture isn't just picking technologies off a shelf. It's about how well those technical choices actually line up with the business strategy, and maybe just as importantly, how well they can adapt when things inevitably change. We've gone from some pretty high-level ideas down to a very practical real-world example, showing how operational needs and technical solutions are truly inseparable partners. So wrapping this up, what does this all mean for you, for your next project, or just for your ongoing learning? As you move forward, maybe the key takeaway is to always challenge yourself. Don't just think about what data you're collecting, but ask why. What specific business problem is this data intended to solve?
And think really hard about how your data systems can be designed not just for today's efficiency, but for tomorrow's adaptability, for scalability, for resilience when those unexpected business shifts happen. It's really about building data systems that aren't just functional, but are truly insightful and ready for whatever comes next.